Brain Science, the podcast that explores how recent discoveries in neuroscience are unraveling the mysteries of how our brain makes us human. I'm your host, Dr. Ginger Campbell, and this is episode 200. You can find complete show notes, transcripts, and much more on my website at brainsciencepodcast.com. You can also send me feedback at brainsciencepodcast@gmail.com. Today's episode is an interview with Sheila Macrine and Jennifer Fugate, editors of a fascinating book called Movement Matters: How Embodied Cognition Informs Teaching and Learning. This episode is focused on the practical applications of embodied cognition. Although the particular focus of Movement Matters is on education, I think the principles are equally important to parents and to anyone who strives to be a lifelong learner. You can get show notes for Brain Science automatically every month if you sign up for the free Brain Science newsletter. You can do this at brainsciencepodcast.com or just text Brain Science, all one word, to 55444. That's Brain Science, all one word, to 55444. When you sign up, you'll get a free gift entitled 5 Things You Need to Know About Your Brain. Because Brain Science is independently produced, it relies on the support of listeners like you. You can learn more at brainsciencepodcast.com/donations. I'll be back after the interview with a summary of the key ideas and a few brief announcements. Welcome to Brain Science. My guests today are Sheila Macrine and Jennifer Fugate, authors of Movement Matters: How Embodied Cognition Informs Teaching and Learning. Welcome, Sheila and Jennifer.
Thank you. Thank you.
I'd like to give you each a chance to introduce yourself and share how you got interested in cognition.
So I guess I'll start. My name is Sheila Macrine. I'm a full professor at the University of Massachusetts, Dartmouth, and I began my career as a teacher. I had started as a special education teacher, and I realized that the kids couldn't read. I went back and became a reading specialist. And then I realized that there was much more to the kids than just the curriculum, that there was a whole social, emotional, cognitive piece to it. So I went back to graduate school and I got a PhD in cognitive psychology and school psychology. And I practiced as a school psychologist for many years. I work with my mentor developing a nonverbal IQ test because that's the Model T of how we identify kids with learning differences. And anyway, in the 1990s, I started thinking and I took courses in graduate school in philosophy along with my psych courses and my IQ courses, et cetera. And I became really fascinated with Merleau-Ponty's work, his notion of enfleshment, and how the Cartesian dualistic model really separated mind and body, but also male, female. And so then I really got involved in thinking about what does this look like? And when you take education courses, they tell us that we've advanced past that with constructivism, et cetera. We talk about it in the book, but we still treat our students as brain-bound learners in the rows and columns like we did 100 years ago. So to fast forward into the early 2000s, I wrote an article about the mind-body separation and how this positivistic model is still very evident today. And I also talked about the feminist position where the female body was thought to be less than, and that the mind and body was separated. And that was in the early 2002, in a book called Body Matters. And it kind of fell by the wayside because I didn't get any traction from it. Nobody really was interested. And so then I started working more with pedagogical theory, feminist theory, critical pedagogy. And then I was at UMass and I heard about this psychologist who was doing some interesting work. And I stopped by Jennifer's office and I said, hey, I heard you're doing really cool stuff. And I was telling her about like my thoughts about we're teaching teachers and we're using this constructivist model, but it's really old wine in new bottles. And it really is not doing anything to deal with the hands-on stuff that Montessori did at the turn of the last century. And all the people that talked about hands-on really kind of doing it. And we relegated that to learning disabled kids rather than reading disabled kids and kids with differences rather than for the whole population when we know even adults learn with body and the environment. So Jennifer said, "Oh, you're talking about embodied cognition." And I said, "Yes, I wrote about it in the early 2000s. And of course, I'm much older than she is." And she was just so excited. And so that's when the collaboration started. I think it was 2015 or 16. And then we just started feeding off of each other. And it just became really exciting. And when we talked to MIT about the book, we pitched the book like we're doing now to say how important this is for educators, that it's really an umbrella rather than a discipline-specific model. And I'm just going to pass over to Jennifer now so she can introduce herself.
Thank you, Sheila. Thank you so much, Ginger, for having us today. So I'm Jennifer Fugate. I'm an associate professor at Kansas City University. I'm in the Department of Health Service Psychology. So by training, I'm actually a comparative psychologist. I did my dissertation work with non-human primates, studied emotion and emotion expression and the evolution of the brain and what language brings to the picture. I had the pleasure during my graduate school of meeting and working with and TAing for Larry Barcelo, who is one of the founders of Embodied Cognition. So it was there at Emory University that I met him and this idea of embodied cognition and really flipping how I had learned cognition and the role of the brain on its side and thinking about it in a way in which the body really matters. And so I always had this penchant for cognition, evolution, thinking about thinking, meta-awareness. Full disclosure that I went on and I was a motion scientist and I still am for the last 20 years. But I recently, after meeting Sheila, picked up this interest again in embodied cognition and thought, how can we think about the body as influencing the mind in our attempt to learn better? And so, as Sheila mentioned, we were chatting one day at UMass. So I was previously at UMass Dartmouth with her. And she's explaining all of this idea of movement in the classroom. And I'm listening and the wheels are turning. And at some point I paused and I said, "This is embodied cognition." And she said, "Well, I'm not sure what that is, but that sounds right." And so I said, "Let me tell you about it from the psychological perspective." Immediately, we knew we were talking about the same thing, just using different language. And hence our collaboration was born.
So many years ago, I think most exposure to embodied cognition actually had to do with somebody coming at it from the robotist point of view. But then after I found out about it early on, I interviewed Art Gunberg, who I'm sure he is, and he was telling me about how kids could remember stories better if they played with toy animals that represented the stories. So he was one of the first people that I talked to. And I've also interviewed Lawrence Shapiro, who wrote the foreword to your book.
Oh, he wrote a wonderful foreword.
Yeah, it was a great forward. And then I am getting ready. By the time this episode comes out, I will have re-released an interview with Evan Thompson. And that's actually an old interview about his book, Mind in Life. But I'm actually hoping to get him back on maybe later to do an update. So, Sheila, would you just give us a brief overview of your new book, Movement Matters?
So the new book is really a Herculean effort because most people that are doing research in embodied cognition are in their own silos. So we have the folks at Stanford that are doing math education. We have the folks in University of Connecticut doing autism. We have folks in other universities doing physics and different things, and nobody's really pulled the group together. One of the ideas that we talked about with MIT, which we really have tremendous respect for, Susan Buckley, who really helped us organize the ideas, that we wanted to be able to show how embodied cognition was this umbrella model and that it was really similar across the disciplines. And so I had started reading about, you must know this, Ginger, about the NIH's translational science research, which is the lab bench to the bedside. And I was talking to Jennifer and I said, you know what, this model is great because in education, by the time new stuff trickles down to the educators, it's like 10 years, and to make change in education, you have to have this whole revolution, like what happened with behaviors and what happened with constructivism. And one of the main problems that we have with changing teachers' minds about things is, the professional developers. Jennifer and I talked a lot about this. So what we did was we talked to MIT and we said, look, we need a translational learning sciences research model where we can take these ideas from all of these scholars that we curated and show how there is similarities. There's a string that we can pull through it. Jennifer, do you want to add anything?
Yeah, so Sheila's absolutely right. I think the real value of this book, beyond pulling together multiple disciplines, is to provide this deductive framework that was lacking in education. We have this idea, and you're right on, Ginger, a lot of work is being done in robotics, some is being done in philosophy, some in neuroscience, cognitive science, psychology, but there's not a lot of crosstalk. And in terms of education, there's really a lack of understanding of some of these theoretical principles. We know they work. Good teachers know that students learn better when they're using their body, but in terms of this meta-awareness. So in this translational learning sciences model that Sheila and I developed, we really try to provide that framework and this, as she said, bench to bedside translational model for the classroom.
I think for the sake of new listeners, we should talk a little bit about how embodied cognition differs from traditional approaches to cognition. Jennifer?
Yeah, I'm happy to take that. Thank you, Ginger. Yeah. So traditional notions of the mind really emphasize this Cartesian dualism, which is the difference between the mind and the body. They were separated, never the two shall meet, except maybe in the execution of action. And so thinking was really based on symbolic abstractions within the brain. So the motor systems, the sensory nervous system, your perceptual systems was really divorced or removed from the picture. So we thought about information enters in through your senses. There's some kind of recoding process. Those ideas have their own language in the brain. They're stored away modulally, or I should say amodally in the brain. And, at some point you need to draw on that knowledge, and then there's an execution into action, a retranslation. So embodied cognition really flips that on its head and says the contents of our thoughts are not just stored in our sensory and motor systems, but there is no necessarily abstraction of that information in the brain. So it's almost like direct connection between the body and the brain. So breaking down this idea of Cartesian dualism, the body is not just a passive observer anymore. It really is fundamental and integral into thinking. So when we're thinking, our brains are actually simulating, this is a word that Larry Barcelow developed, going through all of these nuances, these experiences as we initially coded them. So that when I think about taking a drink of water, my brain is actually activating the states of what it'd be like to drink. Maybe the quench of my thirst, the coldness of the water, all other facets that are involved in whatever actions, these mini simulations recreating the action itself. So when you start to think about this with respect to how we learn, what we're really saying is that if we learn through our body and the information is stored within our body and our sensory motor systems, we really need to pay attention to the nuances that our body and our systems bring to the picture. And those nuanced instances are what build our conceptual knowledge and build our representation of the world. So the more we can use our body, the more nuanced the experiences, which I think later then can be drawn on in a much more nuanced and ultimately more effective way.
So the evidence for embodied cognition, which is, you have a sort of good overview of the book, but what would you say you see as the most convincing piece of evidence for embodied cognition? To me, it's like obvious, but for someone who hasn't thought about it, what do you think is the most convincing piece of evidence?
Personally, for me, some of the neuroscience work, Paul Vermeyer showed that when you read an action word, so you're just reading an action word, you're not performing an action, your motor cortex is engaged. And even to the specificity of the type of action. So participants who are undergoing imaging and read the word kick, the region of the motor cortex that's designated to movements of the feet is actually activated, which says to us that even though those people aren't kicking or moving or punching, under those conditions, their brain is reacting as if they were. So to me, that was as a neuroscientist and comparative cognitive psychologist, that to me was like, oh my gosh, here's the proof I need. And everything else, all the behavioral evidence, of course, contributes to that.
Do you want to add anything to that, Sheila?
Well, I was going to say that in terms of education, the legacy that I spoke about earlier of this Cartesian dualism really positioned the learner as a brain in a vat, like the experiment that was done to say that the body is just this vehicle to carry around the brain, and the brain is where everything happens. And even with the most recent, maybe end of last century, with the brain mapping and everything, I think people are starting to see a cognitive revolution. We call it a paradigm shift in how thinking and learning really happens. And I think that we took the idea of embodied cognition and came up with this like derivative model of embodied learning. So that if you take the idea of embodied cognition, that the brain, the body, and the environment impact how we learn and how we understand our place in the world, that this really has to be seen through the lens of an educator. How am I teaching? Why am I teaching this? And then in the position of the student, like I said earlier, we're still teaching in the old model where the teacher is the talking head. It's disembodied, a disempowered conduit of core curriculum. And so there is an emphasis on the formalisms first, like you memorize, for instance, a formula, and then you apply it. And in an embodied cognition approach to education, we want to see an active participant or a project-based actually doing it and then deriving principles from the actual action of the student so that the student can really internalize this information. We want to see that the teachers' bodies and the student bodies are seen as relevant to the learning process, and to move away from the focus on rote memorization and mindless skills and drills, which is going to be very difficult to change education. But I think it's coming. We'll talk a little bit more about that when we talk about online learning. But the notion of embodied cognition and then the derivative embodied learning can have this sort of paradigm shift or impact on teaching and learning.
So the origins of embodied cognition are often described from a philosophical perspective, but I think we should talk a little bit about how these ideas relate to early ideas in developmental and educational psychology. In particular, let's pick on Piaget because he's one that lots of people are familiar with, even people who aren't teachers, and then he wasn't. Can you talk a little bit about that?
I'll just start with a few things, and then Sheila, I know this is more your end, but in terms of Piaget, I think most of us who are aware of Piaget's work, he says that there's developmental stages, and one of them in which the children first progress is the sensory motor stage, and so that they're learning through their environment. Eventually, there's an abstraction stage or conceptual knowledge stage where that information may be translated. And why I was prompted on this idea here is because embodied cognition, depending on what flavor to which you ascribe, radicalism or conservative embodied cognition, doesn't necessarily preclude the abstraction or a separate symbolic linguistic system. It just says that there either could be another system working in process or subsequently to embodied cognition. So I think especially when we're talking about development, it's important that the way in which organisms typically learn, including small children, is through the body and through motion. Whether that later becomes abstracted or symbolic, it depends on, again, the flavor of the theory to which you ascribe. So with that said, I'll pass it off to Sheila.
Well, I think you really covered most of it. But the thing is that I think maybe we need to back this up a little bit, because the notion that our learning pedagogy, the art of teaching, for instance, is derived from, a very behaviorist model. You talk about John Locke, you talk about tabula rasa, the blank slate, that, it's always this brain-bound notion. And then you get this stimulus response notion of the lecture, the kids sit passively. And then we moved along to sort of this computational model where we have input, output, and thinking that the brain was this computer that kind of processed information and input, output. And all good teachers know that you can say something in a classroom of 30 kids and one kid will just take it and run with it. Another kid will interpret it a different way. We can't just have this computer model where it's mapping one thing onto the other. And then sort of this cognitive revolution happened with constructivism, and Piaget and Vygotsky, who was his contemporary in Russia, he was talking about the same things about how information is constructed in the mind, that it's not input output, that you can say something to one kid and they're going to interpret it one way, another kid's going to construct it a different way, and they're going to hook it on to already understood concepts. The difference was that in Russia, where Vygotsky was writing, we didn't get his work until the late 70s when it was interpreted by a professor at Harvard, but they were contemporaries, and they both came up with this constructivist model. The difference is that Piaget's was an individual model, that this little scientist interacts with the world, and the world interacts with the little scientist, but it's still a brain-bound notion. And then Vygotsky talked about introducing a mediator, that we needed a more capable adult peer teacher to sort of filter the environment so that they could understand it at different stages. People talk about constructivism. I teach constructivism. We teach teachers about constructivism, and this is kind of the model. And we even kind of moved on to the social constructivist model and transactional model, but nobody really talked about connecting the mind, body, and environment and how all of this impacts. Our classrooms look like they did 100 years ago. Our teaching methods look the same as 100 years ago. I think what we're trying to do, and we're making little baby steps, and we're a very small community in Embodied Cognition, is to try to make palatable for educators, and certainly to impact educational policy, curriculum developers, professional development folks that go out and do these trainings that they're talking about. The brain is a muscle. We need to exercise it. The brain gym, everything you can possibly think of. And it still is anchored in this Cartesian brain in a vat, or the kind of model that we abhor. So.
Well, the reason I picked on Piaget is because even, as a medical student, I was taught that as a part of understanding development. And I can remember thinking, well, clearly most people never make it to abstract thought. But in reading your book, the thing that hit me was, okay, when kids are, in preschool and kindergarten, they are allowed to touch stuff and, move their bodies. And then all of a sudden, they're supposed to have outgrown that. And then school gets really boring. As much as I love school, I remember the sharp break from kindergarten to first grade.
Jennifer and I were talking about it, and I said, I went to 12 years of school, and I think the first time that I was allowed to get out of my chair was when I had biolab. But I still sat in the chair, but it was so exciting. It was electric to just get up and move and do something with my hands. But just to your point, yeah, I think it needs to be more evident in schools.
Now a word from our sponsor, BetterHelp. On Brain Science, we often explore ways that we can keep our brains healthy, such as exercise and learning new things. But sometimes we can't go it alone. That's where BetterHelp online therapy comes in. Although I haven't used online therapy, I have found working with a therapist helpful at various times in my life. So I feel good about sharing this affordable option with you. If you're thinking about giving therapy a try, BetterHelp is a great option because it's convenient, accessible, affordable, and entirely online. You can get matched with a therapist after filling out a brief survey, and you can switch therapists at any time. When you want to be a better problem solver, therapy can get you there. Just visit betterhelp.com/ginger today to get 10% off your first month. That's BetterHelp, HELP as in Paul.com/ginger, GINGER.
If I could just throw another example in there, and actually it's one of our book, and I like to talk about when we do these interviews. So people think, oh, this is for little kids. This is how kids first learn. And as you said, Ginger, then they grow out of it. This isn't relevant to secondary education. And we would say not at all. It's a relevant style in which people learn throughout their lives. And we have evidence to suggest people who count on their fingers early on in life, they have better algebra scores in college. So this isn't something that you outgrow necessarily. This is something that really sticks with you. And And I think it's a really, not just a nice message, but in some ways says you're never too old to learn. And learning through your body is a way that so many people intuitively know. Technology schools, they know this. And there's always this kind of negative reaction to, oh, these are not traditional schools. These are somehow inferior. Let's have technical education. And I would love to see, and I think we've mentioned this before, Sheila, I would love to see that idea of doing first and foremost in all education systems, in our public schools, in our colleges and universities. As Sheila said, you ask somebody, what's the most important thing you remember from your education? No one's going to say, Dr. Campbell sitting there telling me about how the body works. It's going to be when I went to the biology lab, or I saw this, or I did this.
Absolutely. Absolutely. Sheila, you touched on this earlier. It might have been Jennifer. There are different theories of embodied cognition ranging from conservative to radical models. But what do they all have in common? Because I think that's what people need to know.
Sean Gallagher came up with this notion of 4 E's. He talked about embodiment, enacted, embedded, and what's the other? I can't remember the last one.
Extended?
Extended. So that's the one I wanted to talk about. He came up with that based on some of the work that Chalmers and Pam Clark did in the 1990s, and more recently with their extended mind theory.
So in terms of, I think the similarity underlining all of these theories, whether they range from the conservatist to the radical approaches of embodied cognition, have to do with the importance of the body. I think where they differ is the extent to which, whether there can be an abstracted system that's working in parallel, that's doing more deeper processing versus shallow processing, whether it happens subsequently later in life. Radical embodied cognition would say that there's never a mental abstraction. Everything is coded in our senses. A more conservative approach, again, would say, well, that's initially how it's encoded, and then something more abstract may happen after that. In terms of 4E cognition, this idea that not just as our cognition is embodied, but enacted as well as embedded, it's the idea that our thought is extended into our world and the affordances that the world has, and that we as people or as a human species pick up on those affordances. So our cognition doesn't just stop with our interaction with our body, it's extended into the world. And we have this great example now of how technology is part of our extension.
During the COVID pandemic, when everybody had to move to online learning, none of us were ready for that. Teachers in schools weren't ready for that. Kids weren't ready for that. And there was no kind of understanding of what the impact was. So we kind of went by the seat of our pants. But people were asking us about how can online learning be embodied? If you're not in the classroom and you're not having this person face-to-face meeting, we talked more about how gesture impacts learning, the movement, the body. One of the examples that we used was, for instance, learning Spanish. One of our researchers was talking about how one word can mean so many different things with the gesture, with the intonation, with the, so there's so many, it's not a one-to-one mapping like I talked about earlier. So when we're talking about learning and we're talking about gesture, you can have gestures online. You can express yourself. You can have hand movements, etc. Jennifer can talk more about, the mirror neurons and everything and how that really impacts learning. But I think it's the tip of the iceberg, because now that we're moving into VR, we're moving into AR and XR, we're learning about how learning can be embodied in a virtual environment. One of the interesting studies that was done was on the extended arm into a virtual reality, and that the brain understood the same touching, lit up the same parts of the sensory motor cortex that you would if you actually touched with your actual hand. So this is going to blow open the idea of being able to have an embodied cognition or embodied learning model in virtual reality. So I think baby steps with the online learning and then moving towards virtual world is going to be very exciting. And I think that's what's going to flip education. They talk about flipping classrooms and everything, but this is really going to be revolutionary in classrooms.
I want to, move on to talking specifically about some of these applications in education, but is there anything else that we need to talk about, just specifically about the embodied cognition, before we talk about the embodied approaches to education?
I think there's one thing that we need to talk about in terms of embodied cognition, that it really taps into our perceptions. And there's the term affordances in our environment, how those affordances help us understand and the complexity of different concepts and experiences that we have. This is going to be very impactful for educators at all levels, basic education, college, university, postgrad, that the professors or the teachers or the educators really understand that to use those hands-on things. And, I think Jennifer tapped on it a little bit earlier, that most educational pedagogy really doesn't connect the theoretical with the practical. And so we teach teachers how to do all these gimmicks and everything, but there's no real deep understanding or this meta-awareness of really how it's working and how I, as an educator, can really impact the learning of our students. So the idea of perception, vision, all the senses being involved, visual, auditory, kinesthetic, tactile, and how we interact with the affordances in our environment. It certainly has helped us with the evolution all the way till now. We've adapted to our environment. We've learned from our environment. We've mutated to our environment. So I think that to use this in a pedagogical understanding is going to be so impactful.
So would one of you define how you're using the term affordance? I've used it in the past, but for the sake of new listeners, tell them where this idea of affordances comes from.
We really mean it in a J.J. Gibson type of way. So a Gibsonian view to affordances is how your body has evolved to interact with the environment, what the environment can provide for you. So an example that I like to share is, for instance, in humans, most of our depth perception is only the result of us moving our heads. If we're stationary, we don't ever move. There's not enough disparity within our eyes to actually see much depth at all. So it's only by moving our eyes and moving our head through space and the affordances of our environment that allow us to perceive depth. So, that's just a really basic kind of example, but it's this idea that how we develop within our Umwelt, if you will, if within our world, by extension, our community and the cultural affordances that we have as well are going to affect how we sense the world, perceive the world, ergo think about the world.
The first time I heard of this, I thought of the example of you go into a room and you notice whether there's something you could sit on. They aren't necessarily chairs, right? But especially if you're tired, I could sit over there on that. Whereas if a bird flew into the room, it would be looking for different things to light upon. If I go into a room that contains computers, that's a meaningful object to me, right? If a person who's never used a computer, you watch an old-fashioned sci-fi movie, right? Where they have, the machines. It's always about the flashing lights, anything that would be real, but it was the imaginary idea of what it would look like. So affordances, they're both because of our interaction with the world, but they also have, like you mentioned, for humans, very large cultural component. I was talking to my personal trainer about this and trying to explain what embodied cognition was and realized my description wasn't as good as I thought. But I said, I was explaining to her what an Umwelt is. And, I said, your dog has a different you because she is perceiving the world mostly through smell, whereas we're perceiving the world mostly through vision. Just that's a very simple level. So are we ready to talk about how we would apply these ideas?
Absolutely. So I think I'll start here and then Sheila, I'll pass it off to you. So one of the things that we're really proud about of this book, in addition to bringing together so many luminaries in different fields, is this idea of a translational sciences learning model, where we've taken this idea, provided this deductive framework that can transcend individual disciplines of teaching and learning. And then we've derived theoretical principles from reviewing the research, going through each chapter and saying, where are the similarities? And then providing core principles and applications based off the science. And so I think that's where, at least for me, this book has a lot of value beyond the academic world for those who are actually practicing and for teaching as well, so that they can go to the conclusion and see, okay, what can I do? So maybe I don't have a lot of money. Maybe my classroom doesn't have a lot of resources. Maybe I don't even fully understand this, but what can I do right now while I learn more about it? And so we're really proud of that applied piece that the book provides.
Great. Sheila?
Do you want to talk about the model, Jennifer, about the principles before we start talking about content?
Yeah, sure. So our model really has 7 different principles. It's to make sense and disseminate the clinical and empirical research, which hopefully we've convinced you that we've done well, to close the gap between research and application, to combine cognitive science and pedagogy, to create this bidirectional conduit, to improve teaching and learning through applied applications. And these include some of the principles that we suggest in the book, to really confirm and also to debunk a lot of these neuromyths. And Sheila knows a lot about them from her time in education, this belief that there are still learning styles and there's right brain and left brain and, exercise your brain with your muscles. And then we also try to, of course, elucidate the conceptual frameworks and provide a framework for sensory and motor learning. And finally, something that we're working on more now, which needs to be further developed, is to create taxonomies and develop assessments and really try to get our message out there and inform policy and curriculum change.
So what are the key principles of embodied learning? Action matters. Imagining or mental simulation can activate action-based knowledge. Observing the actions of others can activate action-based knowledge. And simulations are sometimes manifest in gestures and forms of representational action.
So I think that actually comes from Alibali and colleagues. Those were principles that they had come up with initially. They certainly do map on to the principles that we have outlined. I think in terms of some of the principles we have, they're slightly different in the idea that they directly relate more to action principles. So if I can give just an example of some of those, I can do that here. So let's talk a little bit about observation and mirror neurons. So when Sheila was talking about online education, we're talking about this idea that when you can still share your gestures, as I'm doing now, watching myself on the screen, your facial expressions, all of those things are still present. And we know from the mirror neuron system within the brain reacts to other people's gestures and movements as if you were doing them yourself. And we think that could be even the basis for things like cognitive empathy. One of the principles, for instance, based on that is this idea that observation imitation is a powerful source of learning throughout the lifespan. So how could a teacher use this? Well, one of the things we say is that teachers could use eye gaze and joint attention to help communicate information in their movements, paying attention to not just their movements, but student movements as well. In fact, when we go back to the realm of gesture, we know that when people are gesturing with their hands and their hands are doing something different than what they're saying, that actually tells the educator that there's an important disconnect here and that we need to go and revisit that. So watching for that disconnect. Teachers and students can also work together to actually correct and manipulate others' hands. There's this great example from one of our colleagues who spoke with us at APS where someone's describing a triangle and he's describing the triangle and the other student is watching him describe the triangle, which of course he's doing things like this and he's doing it at the same time. And it's fascinating because at some point he starts to kind of intuit what the actual person who's describing is going to do. And there's this simultaneous kind of convergence of the two. And you can really see that he's understanding at that moment what's going on. Other than that, I would say we mentioned that, of course, the importance of bodily-based movements in the classroom. These don't have to be necessarily high-tech AR, VR. Clearly, there's a lot out there that can be used, but even just simple manipulatives are really important for body-based learning and that imitation that a teacher can do to show a child or a student.
I want to take a moment to talk about our longtime sponsor, Text Expander. I often mention that I use Text Expander every day and that you can use it across all your devices and types of software. But today I want to explain how to create a snippet which is the main tool that makes Text Expander so powerful. The snippet is a short string of characters that is automatically replaced by whatever content you want to reuse. For example, I use semicolon BSS to represent a list that includes a link to the Brain Science Facebook page. I usually start my snippets with a semicolon because there aren't any real words that start this way. Another cool thing is that you don't have to remember all your snippets because they are easy to find within Text Expander by using keywords. If you want to give Text Expander a try, just go to textexpander.com/podcast to learn more and to get 20% off your first year. That's textexpander.com/podcast. And be sure to tell them that you heard about Text Expander on Brain Science. One of the things in the book that's a little bit of a challenging topic that I think we might talk about is the whole idea of modal versus amodal, especially as it applies to forming abstract concepts.
Yeah, so amodal really, again, and this is the work of Larry Barcelo, comes from this idea that there's a localization of function in our brain and that our brain is very compartmentalized. It really fits with this faculty view of psychology. So that things are abstracted and locked away, and there's a separate memory system and a separate linguistic system, all of these different systems in the brain. And certainly there are different systems, but what we do know is that the brain is obviously connected. It's connected through millions and not billions of neurons. Different neurons feed different areas of the brain. There are cortical layers of each part of the brain that innovate other areas of the brain. And so now a more recent view of neuroscience suggests that the brain is less reactive than it is predictive. And so the brain is constantly trying to take in information and match it to something that's experienced. And so it's running all of these mini simulations, if you will, that are based on past experience to say, hey, what is this most like? And we think that those simulations are embedded throughout the brain in probably some key networks, but certainly not in a way where it's abstracted into some other kind of thought. And that idea of abstraction or modularity within the brain really, again, comes back from the computer metaphor of the brain, that everything is stored statically and that we just go in and reach out a memory and there it is exactly the way we encoded it. And of course, it's not static and it's not symbolic in the case of embodied cognition.
I mean, I think memory is a perfect example of overwhelming evidence for embodied cognition because we now know that when you recall a memory, it stimulates the parts of your brain that were active during the experience, aside from the fact that the memory changes every time. You know, memory is definitely embodied from that standpoint. So you had an example in the book about learning a musical instrument, a bassoon, for example. Does either one of you want to take that and tell us what we learn from that? The difference between when a person describes to you a musical instrument versus you actually get to see, touch, hear it?
The idea that I think it was Oliver Sacks wrote this wonderful book called Musicophilia. He's a neuropsychologist or psychiatrist in London, and he worked with a lot of stroke victims. And he had a small subset of stroke victims that were concert pianists. And he was able to sit them down. They couldn't take care of themselves. They couldn't walk across the street. They couldn't self-care. But he could sit them down in front of a piano and put their fingers on the keys, and they were able to play a whole concerto. It was a fascinating book if anybody's interested. But the idea that music is a multi-sensory, really a very good example, Ginger, of embodiment, and the idea that music can really touch us in many, many ways. Not only the person playing the music, which is mind, body, environment, emotion, perception, all kinds of different things, but it also touches the listener. The listener becomes electrically involved. If, you know, of course, if you like that kind of music, but if you listen, you can empathize, you can feel it. All your sensory system is activated with music. So I think that's a wonderful example of how embodiment really demonstrates this notion of all of the senses and the environment and exploiting the affordances in the environment that really activates all of these things. That it's a really great example to show educators how this mind, body, physical, auditory, kinesthetic, tactile, all of these systems work together to really produce our deep understanding of something.
I think, this is a perfect example. I do think there's something special about music that I'll say in a moment, but it's a perfect example of how students learn to play the piano. Nobody sits down and says, let's learn how to read music first, right? The teacher sits them down and they start playing. And eventually they learn how to read the music, derive melody and tempo and all of these other aspects, but it's done through the movement. And in terms of just elaborating on what Sheila said, when you hear a piece of music that you resonate with, all of us, we either get up and we dance or we sway or we move our head. For me, that's another perfect example, a more anecdotal example of the fact that music has to be embodied, because we want to move our bodies when we hear music, especially music that really touches us. And I think it also speaks to something that music is just at the heart of so many cultures and is really an important cultural aspect too. And we can see how different cultures have different values in music and different musical instruments and tones and tempos and beats. But it becomes part of who you are in a very literal, embodied way.
Yeah, I was just going to say it doesn't have to be high tech. I still have a very strong memory of way back in 1967 when I was in the fifth grade. We used to have to watch this music show on public television, which was in black and white, but an episode about the Nutcracker. So our teacher decided that was going to be our thing. And so we started playing the parts, and we had we're doing a mural, and everybody got to pick what characters they wanted to draw. And, none of us had a clue what our characters in the ballet looked like, right? We imagined from the music. And I mean, that's still probably my absolute favorite piece of music. So it doesn't have to be high tech.
Well, we mentioned in the book that low tech and high tech, embodiment can be in any way. I mean, even with autistic kids, for instance, Lova's method of hand over hand speaking and having them listen, or back tracing when we trace letters on the back of kids' back to help them understand what a shape looks like. So low tech is just as important on many levels. It's just, I think, to your point, is that embodied learning really is exploiting any of the affordances in our environment, just exploitation of any affordance in our environment.
What sort of empirical evidence supports an embodied approach to education? I know that you've got lots of examples in the book, but I was thinking that you might like to share at least one example to give my listeners a taste.
So maybe reading would be a good place to start. Reading has gone through many iterations following this model of behaviorism, constructivism. And so our traditional model of teaching reading, well, let's put it two different ways. The elite class was read to from very early age and sort of internalized this notion of language and developed a schema for how language looked and how stories are told, and developing a story grammar about how the author communicates. As a result, I think, of a behaviorist model, we started to do a very bottom-up method of teaching reading, where we would teach letters first, then blends, then sounds, then words, then sentences. And maybe kids didn't really have a book in their hand till third grade, believe it or not. And then I think at the end of the 70s, we started to have this whole language discussion where we want to mimic what middle-class parents did to read to kids so that the kids could internalize the schema for language, understand that reading is really an author telling you a story, not this sort of bottom-up methodology. And we found that this bottom-up methodology of letters, sounds, this kind of thing, that kids had, especially kids that had learning differences, had a lot of difficulty putting these novel little unrelated bits of information together to understand reading. And with the latest neuroscience, we really understand that word recognition, word calling is in a different part of the brain than reading comprehension. That comprehension is really in the language portion of the brain. When we taught reading in those days, there was a real rejection of this behaviorist model to a holistic model The problem with the holistic model, where we read to kids and then we expected the kids to develop this schema, and some of the kids had never been read to before school, there was a backlash to that because they said there was no skill development for the kids that needed skills. There was no skills to be taught. And then we moved to a model of using authentic literature, reading to the children, and then trying to pull out like word recognition and definitions and spelling and everything from an authentic piece of text. That was fine. However, we now know that there's a lot more to reading than just teaching somebody these skill sets, that using an embodied model, as we talked about all along, where acting out characters for kids to learn to read. The Glenberg group has done a wonderful job with the project, and it's a computerized model. Now, first of all, they did it with actual characters, movable characters, so manipulatives, where it's called Move by Reading. So they simulated the story that was read to them so that they would take little characters and move them around, and they would retell the story. So this really helped the kids understand what comprehension was about, because many kids think it's just sounding out words and they're not making connections. So I think this model of using an embodied learning model with reading really can help kids that have learning differences, but certainly impact kids that really kind of understand reading, because they go from this physical manipulation to imagined manipulation, where they can start to do this now on a computer screen, where they can move the characters on the computer screen. He has found that this embodied-based approach to reading intervention has really improved reading skills. They reported that the actual data with using the manipulatives, they had really great results, but they also reported a similar effect size with the computer model. And now it's also been translated into Spanish, where you have kids that speak another language or have a thinking language and then trying to do this code switching when they have to learn to read, that this model is really going to be great for helping students at an early age to internalize story grammar and understand that comprehension is really just somebody telling you a story, not sounding out words and that kind of thing. So the reading application is really interesting to me, and I think it's going to be important to educators.
The great thing, too, is that Glenberg and colleagues have now shown that this effect of learning through this program, Moved by Reading, extends to other genres as well, including mathematical problem stories. And they even found that children with learning disabilities had better free and cued recall for propositions, objects, actions, than for those in the sentence than learning in a disembodied manner. So there definitely is, this is, I think, one of the areas, and rightly so highlighted in our book, where we do have really good behavioral evidence from the classroom that says, hey, this technique works. Where we still lack, and what we hope that to do with this book and with more collaboration, is to make that bench to bedside leap, because we still have a lot of people who are writing about it theoretically, empirically done in the lab maybe, but haven't then taken it into the classroom. And so Glenberg and colleagues are unique in that sense, that they're one of the few who've really taken the science and then said, let's test it in the classroom. And I think that's ultimately what Sheila and I are trying to advocate for in this book.
Along those lines, there's empirical research that says that handwriting versus keyboarding, that taking notes by hand really impresses the language portion of the brain, where keyboarding becomes really rote memory, goes to the rote part of the brain. That the empirical evidence shows that college students, for instance, were able to recall more information when they wrote their notes by hand as opposed to transcribing on a keyboard. We surmise that, and certainly the researchers surmise that, it's because they can't write every single word, but they're already chunking the ideas together and it's sort of internalizing. So this notion of embodiment is just so exciting for us, absolutely exciting.
So back onto the whole handwriting thing, the example in your book that actually really made me decide I wanted you guys to come on the show was the chapter about handwriting and literacy, particular learning to handwrite the letters. Would you talk about that?
Sure. This is an idea that we had been tossing around, and certainly is a totally novel idea. But I think what handwriting, especially cursive, brings to the picture, and of course there's a push not only to eliminate cursive, but eliminate handwriting altogether, is this idea of having very nuanced instances and representations that can later be drawn upon. When you're typing on the keyboard, you're very little motor movement, if you can think about it. When you're moving a pencil or a pen to either print letters, and certainly in the contextual flow of cursive, what you're doing is just providing the brain with more information. So the richer the input, the richer later the simulation can be. And that's what leads to increased learning, increased memory, because there's an increased representation that's coming from those fine movement skills.
In the book, Karen James, who is doing wonderful work with PET scans and has been able to suggest that children that print and write it has a greater impact on their ability to read. Going back to what Jennifer said, the national core curriculum, which kind of dictates every state standards, actually took handwriting out of the core curriculum, so that cursive handwriting was absolutely taken out for 5 years. It was just recently put back in. So schools weren't teaching cursive writing any longer because they were introducing keyboards in kindergarten. We're fighting tooth and nail against that. Certainly students should be computer literate, and certainly keyboarding is a great skill. But we believe that the handwriting is a very vital part of development in terms of language and learning.
And it makes sense when we learn how to read or have learned how to read. One of the things that we do is that we can recognize letters even when they aren't exactly perfect and maybe have pieces or are crooked or whatever. So it makes sense to me that part of that would be helped by learning to write letters, because when you learn how to write, it's at an age when you can't really write perfect letters, right? And so you're automatically learning that, what's it called, invariance or whatever. And so it makes sense that keyboarding wouldn't have the same effect, because every time you type an A, it's the same. And the other point that she made in that chapter, the difference between writing on paper, which has its own certain level of difficulty for a small child, versus writing on a tablet, which is actually very difficult. I mean, I don't know about you, but I've experimented with devices to write on, and none of them feel like paper. And as a person who learned to write on paper, I want it to feel like paper. But I hadn't thought about the fact that just the difficulty of trying to write on a slippery surface. I'm going to say a person I meet that has a little kid, I'm like, "What's your kid? Handwrite." And it doesn't matter if it doesn't look good.
It's very important.
I've been ever since I interviewed Marianne Wolf years ago, I've been saying, read to your kids. I'm adding this to, and let them write their letters. Fortunately, you can do that at home, whether your school does it or not.
Yeah, well, the surface is very important. It's very astute that you mentioned that, because when we have severely learning disabled kids or severely reading disabled kids, we use sandpaper for tracing with their fingers. And we make the letter, we say the letter as we're making the stroke, they're listening, then they copy, simulate, or imitate. So actually, it's really important that the actual surface can make an impact on learning.
And I think that fits nicely too with this idea of electronic affordances too, because one of the chapters in our books highlights the importance of when we're reading online, we're much better when we comprehend when it simulates an actual page turn in doing this, sliding through, as opposed to scrolling, because that's unnatural and does not simulate how we read books. So when if we're on a Kindle or something where you can slide through the pages and flip them, it really is mimicking the environment better, and people tend to have better comprehension when presented in that format.
And of course, in the book, there's other examples. There's a focus on STEM learning, science, technology, and what's the E stand for? I can never remember. I should know that. I have 2 degrees in engineering. But anyway, there's a lot of examples of the importance of this in both math and science. I can remember reaching this point at which I could not visualize anymore. That was where I got stuck. That's because even when it's highly theoretical and highly abstract, it's embodied at some level. I think we have time to talk a little bit about the use of virtual reality, because that's a really exciting area.
One thing we can say as we relate to the STEM field, so one of our contributors to the book, she and her husband are developing ways for which students to learn physics through their smartphone. And I don't think, at least I didn't realize, and probably most of the listeners don't realize, that your smartphone already has a bunch of things that it uses to map location, including things like accelerometers, and can measure gravitational pull and mass and all kinds of different things. And so our contributors, the Vieras, have actually written a program that students can use their smartphone to learn about real physical properties in the world. Everything from gravitational pull to acceleration, just by moving their phone through the environment. And it's really fascinating because here it's something that doesn't really cost the student anything. The already majority of students have access to smartphones. And what you see and what they prioritize in their chapter in the book is that students often come in with these misconceptions, this idea of our folk psychology. We think we know how things work, and they're frustrated because their phone is doing completely different things than they envision the way the world should work.
Watch too many superhero movies.
Right. What do you mean? I can't fly through outer space. So, and then there's this realization all of a sudden that, oh my gosh, so this is how, as I move through the environment, now I can see or envision magnetic fields that I would never assume magnetism to work this way. And so it's by them moving through the environment with the smartphone that they eventually learn these principles. But to speak to your other point, Ginger, and my apologies for the interruption there before, is I'm part of now Kansas City University, and Sheila and I's current work is focused a lot on behavioral health and the behavioral health sciences. So Kansas City University is a graduate program for medical students, clinical psychologists, as well as the biosciences. And we have one of the cutting edge centers for simulation where students can learn to practice medicine in a virtual environment. So we have both a simulated environment with interactive mannequins, but also complete AR, VR, in which students can work with virtual patients and go through case-based learning and learn how, by actually doing, to assess individuals. And the great thing is that this center was established right before COVID hit. And so we were one of the only medical schools that was able to continue their education for their practitioners because we had this center in place. So it's a really wonderful Center for Integrated Medical Intervention. And I think we hope, Sheila and I, to emphasize what AR and VR can do in behavioral health and medicine as well. I think that's maybe our next big push.
I just want to take a moment to remind you about my book, Are You Sure? The Unconscious Origins of Certainty. It is available in both paperback and ebook formats from all of the major online booksellers. I hope you will consider giving it as a gift. And if you're interested in an autographed copy, just email me at brainsciencepodcast@gmail.com.
So actually going from basic ed now to the behavioral health sciences is going to be very exciting, but it really brings to mind the 4 E's of embodied cognition. So it's embodiment, enactivism, embedded, and extended. So the 4 E's. So we enact on the affordances in our environment. We have our learning embedded or situated in a particular situation. And then the extended mind, which is really the Clark-Chalmers model. And this is what we're talking about in terms of extended mind. Clark and Chalmers, actually, Andy Clark endorsed the book on the MIT site. We're very excited and grateful to him. But the idea of the extended mind, he talks about the fact that we use our phones to a great degree. You know, I was talking to Jennifer, and my husband asked me what the phone number is of, I don't know, somebody in our family. And I said, I have no idea. I'll check my phone. So we have this notion of cognitive offloading to our technology. And Chalmers and Clark talk a lot about different applications of this extended mind. First of all, they talk about the blind man and the cane. And they were talking about, like, where is the perception? Is the perception embedded and brain bound? Is it in the hand? Is it in the handle of the stick, or is it in the stick that hits the pavement? He talked about this perception is really extended beyond the body for them to negotiate their environment. He also gave the example of cab drivers in London, the old model of the black cab drivers in London. They had to memorize maps. And this extension of knowing their environment, being embedded in their environment, moving through their environment, memorizing all of these different routes and everything, they actually increased parts of their brain size as a result. So the notion of an extended mind into virtual reality, which is our next kind of project that we're working on about embodied cognition and how embodied cognition informed embodied AI, is getting to be this notion of how virtual robots now are learning, rather than being the computational model, are learning not to be predictive, but reactive in their environment. And they're actually learning to negotiate their environment rather than being programmed. So the old model of a robot was that they programmed in, and then they would do something. And Boston Robotics is really kind of on the cutting edge with the actual physical robot. But at Stanford now, they have this model of these kind of unimals. They're called universal animals, where they actually have evolved on their own to negotiate their environment. So they have these little stick figures, and the stick figures, rather than being programmed to walk up a terrain or something, or they've actually adapted to the affordances in the virtual reality and developed extra limbs to negotiate their reality. So we're very excited about the fact that now embodied cognition is now informing embodied AI in terms of this new model of artificial intelligence. So this notion of extension is very exciting for us too.
I think the first time I was aware of this idea was Sandra Blakesley, I think, that I interviewed about body maps. And of course, some of those famous experiments with the monkeys and the rakes and how the rake becomes part of the body map. And anyone who's played a sport, tennis or anything, you feel like your racket is part of you. It's the same as the cane. So kids, they already have this skill. They've all grown up playing video games. So I guess that's why the virtual reality has a lot of promise for being able to have something, even though it doesn't sound at first glance as like an embodied approach, can take advantage of how our brain works and use this. So it's really exciting stuff. What else, Jennifer, did you want to share?
I think what Sheila was talking about at the very end is really super important and super fascinating. So again, this idea of modern neuroscience suggests that our brain is really predicting rather than reacting to the environment. And so when you program robots, obviously there needs some initial fodder for it to work on, but instead of specifying the steps, it's learning through, in the case of these unimals, they're learning through their environment how to then think and ultimately evolve and adapt. And I just think that's a really fascinating way that robotics and engineering is moving towards and embracing these principles of embodied cognition. Like I said, so many different people in so many different fields are thinking this way, but there's still this lack of interaction among disciplines. And I think hitting the robotics and the AI field, that's our next go-to audience.
Wasn't Brooks the one who said that the world is its own best model or something like that?
That's right. Absolutely. Yeah. And so they've been talking about, he and others have been talking about, embodiment for a long time, but they're, I think, really the exception to the rule in the case of AI. So getting, again, people just to understand embodied cognition and start thinking about it similarly.
He was one of the really early on people in robotics that talked about embodiment and how to reconceptualize it. And it was theoretical at that time, but now it's not. But to follow up on Jennifer's point about embodiment and behavioral health, our model has always been an umbrella model. And that's why this K through college level stuff that we just did in the book is important for educators, pedagogues to understand that embodiment is not discipline specific. And that's where we got to with the Simulation Center for Behavioral Health. We have professors teaching who are kind of learning the technology, but they don't know how to apply their pedagogical understanding or really having an understanding of how, just like you mentioned, Ginger, how the virtual reality can be embodied. So we're hoping to have an institute, get funded for an institute at Kansas City University at the Simulation Center to educate behavioral health educators and how to really impact in moving from the see one, do one, teach one model that's over 100 years old, which is still relevant, but I think we need to expand that model a little bit more in terms of the virtual reality and all the technology in health sciences.
Jennifer, I have a question about your simulation lab. If a medical student is interacting with a virtual patient, real people, they're always really different. Like CPR on a mannequin is so annoying because it's not like a person. So I'm curious as to how you model what real life conversations are like.
Yeah, and I have to be full disclosure here. I have not worked much with the interactive mannequins, but whoever designed them for the center has done a fantastic job, because I can say they really are interactive, and you can ask the mannequin a question, it will answer. And the question's potentially limitless to my knowledge. So again, I'm relatively new to the university, but my experience comes actually through my son, who had the privilege of going to take your child to work day. And so I got to see the simulation center from his perspective, in which they had the children actually try to solve a case. And this patient had asthma. So I got to see the children asking the mannequin all kinds of questions. And my point is, the questions that children were answering were not something that you could think of scripted, right? They asked all kinds of crazy questions, but a mannequin could respond. And then the great things, they could actually practice administering different medications. It was hooked up to the vital signs. You could see how the vital signs shifted as a result. So first, I would say I'm enamored by whoever programmed this or is doing these virtual mannequins, but they really go above and beyond the kind of the old dummies, if you will, where they're just plastic. That is a great part of the center. The other great part that I want to highlight is the AR, VR as well. So the complete virtual interaction with simulated patients.
A very important point possibly to make is that we do have this amazing ability to extend our sense of our body into a virtual reality. I just went to the Van Gogh immersive experience. Are you familiar with that? And it has a virtual reality part at the end. And I've done other ones, and you always want to reach out and touch. Anyone who is skeptical really needs to look for an opportunity to do a good virtual reality experience, because you'll get a better sense of the way that it tricks your mind. It really feels like you're there, and it's so different from watching a video game on a TV set.
All of our kids that use Pokemon Go have an experience in having characters on the street. And I mean, they're way ahead of us, way ahead of us. So they understand what it is to have an avatar in there and to identify them, interact with the avatar. So, I mean, there are some games that really are adaptable. But one of the things that we want to do is to help professors develop pedagogy that's going to be really based in the theory and the practice, linked in a virtual world.
As we're getting ready to wrap up, is there anything else that we need to talk about?
I'm just very excited about people being exposed to this. And certainly, Ginger, you have really been very generous to invite us. As I mentioned earlier, the embodied cognition world is a very tiny community. And for us to even curate the empirical and behavioral applications, one of the things that we did ask our contributors was to take their empirical studies and make applications for the classroom. So this is kind of a new kind of thing. And I think that we need to do much, much more. And like Jennifer said, they need to be vetted in the classroom. We need to bring it to scale, and we need to develop taxonomies and assessments. And this is going to be our project for the next 5 years, hopefully. But that's the forward look. And I don't think that we're limiting it to the basic ed college, but really professional level education. But now reaching out and being inclusive of the embodied AI group, which I think they're going to be very happy to have us on board as well.
I'm most proud of this book because I feel like we do reach a vast number of audiences, and we hope that the listeners agree. But we're really trying to target not just academics and researchers, but educators, policymakers as well. And I think that we do that well and really start to open the lines of communication between these different silos and these different fields, and really bring the key people together and really start this idea of translational science, which is, of course, why we named our model the way we did.
Right, because in the rapidly changing world, we can't have a lag of 10 years. My traditional last question is advice for students. It can be students interested in education, students interested in psychology, science, whatever you feel that you would like to give advice about.
Well, after teaching educational psychology for 20 years, I would hope that students would be open-minded, teachers would be open-minded to this new model. And certainly on Jennifer's point that curriculum developers, publishers will add it into the textbooks. I think it's really important for students of all levels to understand this, and certainly teachers and educators and university academics to understand this embodied movement. While it's still small, it's germinating, and we're hoping that we can continue to make a contribution.
Yeah, I don't think most students even realize that they're learning within a tradition or a theory. And just to recognize that the information that you're being presented with, often by an educator in a textbook, does come from a theoretical discipline. And unfortunately, in the case of embodied cognition, there aren't a lot of textbooks that teach cognition, and certainly in education don't teach it from an embodied perspective. And so knowing that this is an alternative model, how it plays out, and the importance of just knowing how the information that you're learning comes from a theoretical tradition and how theories and paradigm shifts happen. I think that's really important on kind of a larger scale, just in the terms of developing a good scientific mind.
I mean, like one of the points I got was I'm very aware of how embodied cognition is different from the computational point of view. I hadn't really thought about how the computational view is embedded into that longstanding tradition that is kind of our folk psychology point of view. In fact, I've had guests on here, Michael Graziano in particular, who said, we don't need to know what our brain's up to. So naturally, it feels like it's something non-physical. So you really have to overcome your intuition that your mind is a non-physical thing.
Absolutely. Absolutely.
Okay, well, this has been fun. I appreciate you taking the time to talk with me today.
Well, thank you so much, Ginger. It was a pleasure.
Thank you. Absolutely.
I want to thank Sheila Macrine and Jennifer Fugate for their pioneering efforts in editing Movement Matters, How Embodied Cognition Informs Teaching and Learning. If you're an educator or work in the field, I highly recommend this book as a primer for introducing embodied learning to your peers. I would love to hear your thoughts about this episode, so feel free to email me at brainsciencepodcast@gmail.com. There are complete show notes and episode transcripts available at brainsciencepodcast.com. Before I review the key ideas of today's episode, I want to reflect briefly on this landmark episode number 200. Mainly, I want to thank each of you for listening, and especially those of you who keep the show going with your financial support. Some of you have been listening since episode 1 back in December of 2006, and that means a lot to me. I'm also sad to mention that several longtime listeners have died in recent years. I always mention my email twice in every episode, but I want to emphasize that I really do want to hear from you. Your feedback, along with your financial support, keeps me going. I do want to limit my announcements today, but I want to mention that in April 2023, I hope to take a cruise from Amsterdam down the Rhine River to Switzerland. I'd very much like to do a listener meetup and possibly a public talk, most likely in Amsterdam or Zurich, but I need contacts in Amsterdam and Zurich. I also need to know how many of you are interested in attending either a talk or a meetup. If you're interested, please email me at brainsciencepodcast@gmail.com. I picked this month's book, Movement Matters, for 2 reasons. First, I have been interested in embodied cognition since I first discovered it back in 2007. Appreciating that our mind is embodied shifts the way we see ourselves and our place in the world. The other reason I chose this book is that I know many of you are involved in education, but even if you don't have any formal connection to the field, I think it's important to understand how embodied cognition impacts how we learn. If you're new to the idea of embodied cognition, I encourage you to consult the show notes in your audio app or go to brainsciencepodcast.com for the complete show notes, because that's where I list many of the previous episodes about embodied cognition. The episode transcript also contains additional links. One reason that I consider embodied cognition to be one of the core themes of brain science is that it challenges the traditional dualistic approach to the mind. But it's one thing to claim that science has moved beyond the separation of mind and body. Dualism is so embedded in our cultural approaches to education, it can persist almost without our awareness. This is reflected in the fact that classrooms, for the most part, look just like they did 100 years ago. Adding laptops or tablets may even exacerbate the tendency to see students as brain-bound learners. Ironically, body-based approaches to learning are generally seen as inferior, restricted to special education, or as something that students are expected to outgrow. This is contrary to the growing evidence that all cognition involves interaction between the body and the environment. This interaction is a crucial component of learning. For those of you who are many years past your school days, I encourage you to reflect on what comes to mind when you think back. What examples of hands-on learning do you remember? How were these different from listening to your teacher lecture or trying to read a textbook? Movement Matters: How Embodied Cognition Informs Teaching and Learning by Sheila Macrine and Jennifer Fugate is recommended if you are an educator or you work in the field. It's a great primer for introducing embodied learning to others. If you want to learn more about embodied cognition, please go to the episode show notes in your audio app or visit brainsciencepodcast.com. If you haven't already done so, please follow the link in the show notes to complete a brief audience survey. And don't forget to sign up for the free Brain Science newsletter so you can get show notes automatically every month. Just text Brain Science, all one word, to 55444. Brain Science, all one word, to 55444. You can also go to the website. When you sign up, you will get the free gift entitled 5 Things You Need to Know About Your Brain. Next month, we'll be talking with William Harris about his book, Zero to Birth: How the Human Brain is Built. Until then, I hope you will check out my other podcasts, Books and Ideas, and Graying Rainbows. Thanks again for listening. I look forward to talking with you again very soon. Brain Science is copyrighted by Virginia Campbell, MD. You may share the show with others, but for any other uses or derivatives, please write to brainsciencepodcast@gmail.com for permission. The theme music for Brain Science is Mind Fire, written and performed by Tony Catraccia. You can find his work at syncopationnow.com.